Okay, this is outline lesson 5. And we're going to talk about the exponent rules first because I do believe that they're very important. They come up a lot in lesson 5 to get through our problems. So we're going to talk about exponent rules, we're going to talk about radicals a little bit, and possibly do about one example, and that's all we're going to have time for. So, what are the exponent rules? Has anybody got one?
I have them written down.
Did we write them down already this year?
Yeah.
We're going to do them again because I think some of us probably lost that part of our notes already. So we're going to do them again. What is one of them? Power of a power? So that would be x
to the x
to the n
Thanks.
to the m power. That's a power of a power. And a power of a power, we do what to exponents? Multiply. What's another one? The distributive one, there's no distributive property of exponents. Quotient property. So, product of quotients? Or quotient of product? Quotient, power of a quotient. There's a couple different ones there. So we can say, hey, if I had a quotient with a power on it, means a fraction with a power on it, what can I do? I can basically say distribute the exponent to the top of them. Three. What's another one? 0, 1. Okay, that's a good one. Anything to the 0 power is equal to 1. I'm glad more people are saying 1 than 0. We're getting good. We're getting to the point where we're actually starting to remember some of these. Another one. How about power of a product? What if I had two things multiplied together that have a power of m?
No, you did.
Not adding them. Yeah, we kind of act again like we're distributing the exponent, right? So it's a to the m, b to the m. Notice that there is multiplication between those two because they are multiplied inside the set of parentheses. Oh, what about just the quotient of powers? What if I had x to the n over x to the m? Subtract what? The exponents. So it becomes x to the n minus m.
Are you going to give us a quiz on
That one's the quotient of powers.
If you did, could you tell us today?
Well, we have to have a review day, Jonathan.
Okay, 6. What's another one? There are 7 of them. What's that? When you add, yeah, we just did the subtracting one. The one you add is the product of powers.
What was the last one you had? What was it called?
Hold on. Quotient of powers, yep. This one is the product of powers. X to the n times x to the m. You then can take those with the common base. The base stays the same. It's x to the n plus m. And there's one more. Yes, the negative one. Negative exponent rule. We don't like negative exponents per se. Negative exponent rule. So, if I don't like negative exponents, if it's on the top, it ends up going to the
Bottom.
and the exponent becomes positive. Or, what happens if the exponent
He's on the bottom.
is negative on the bottom?
Then you move it to the top and it becomes positive.
Right. The whole
Thanks.
thing comes to the top and it becomes positive. Now this can be a tricky one, number 7. I'm going to give you guys an example. What happens if I had 2 plus x to the negative third power. And then, wait a minute, I'm not done yet. All over h. How can I fix this so I don't have negative exponents? Now, this is not going to be fixing it all together because it's going to create something we don't like as well. But how do I fix this, Nate? He just wants to put x to the third on the bottom. Here's the problem. What is that negative exponent on? On x. What's between the x and the 2? It's a plus sign. So is there really a bottom? Or what should I say? No, is there a bottom? You can't take something from the top and bring it directly to the bottom because not everything is multiplied. So I cannot bring it down here. I have to bring it to its own bottom. What's really underneath x to the negative third power? It's a 1, just like what's underneath 2. A 1. What's underneath h? A 1. So what it becomes is 2 plus 1 over x to the positive third power all over h. It's going to come in handy that you guys realize this. That if there's a plus or a minus sign between two things, you can't all of a sudden bring it to the bottom of the whole thing. Just its own individual fraction. So only when you multiply and divide do things go wholesale up and down. So back in Algebra 2, we talked about rational exponents, which means fractions as exponents. And there are ways to switch that from exponential form, which is on the left, to radical form, which is on the right, with the nth root of x to the m power. We also, and I forgot to type this in here, there's another version of this. And that other version actually ends up being the nth root of x to the m power. So make sure you write that down in there as well. Where do I get these from? I get both of those from the fact that x to the m over n can be broken apart. I can break it up using power of a power because I have to multiply, right? So x to the 1 over n to the m is equal to x to the m to the 1 over n. You guys agree with that? Power of power. I have to multiply. What's 1 over n times m? It's m over n. What's m times 1 over n? It's m over n. Now, I'm going to connect them to show you which one goes where. This one is this one. You can see that the m's on the outside, right? And this far one would be the one that you would get that answer for. So a question you might be asking is, why is this important to know? I'm going to go on the bottom here. I'll erase it eventually here. But what if I asked you 8 to the 2/3 power, and I said evaluate that, and I don't let you use a calculator? Well, according to what we have up top, I could split this to two different camps. I could say this is 8 to the 8 squared to the 1/3 power. That's one option, right? Using power of a power. Or I can say this is 8 to the 1/3 power squared. Well, we can they're the same answer, but one's easier to do. What's 8 squared?
64.
It's 64. And it's 64 to the 1/3 power. Yeah, what's 63 to the 1/3 power? What times itself 3 times gives me 64. It's not something that's coming to your head really quickly. Now, let's think of it at the bottom. 8 to the 1/3. We'll finish that top problem in a second. 8 to the 1/3 power. What times itself 3 times is 8? 2. And so it becomes 2 squared, which is 4. Hey, go back up to that 64 to the 1/3 power. The 64 to the 1/3 power is 4. Because 4 times 4 is 16, and 16 times 4 is 64. So, this has implications on making things easier for ourselves or making things take longer or harder for ourselves. Because I can split up exponents or rational exponents in a way that makes it easy for me to do without a calculator. Otherwise, the numbers, when you start to square and cube and all of those things, the numbers, they get large very quickly, especially the larger the base. So I'm going to break it down first on the bottom to get that 2, and 2 squared is 4. We're good to go. We also talked about, when we were doing the homework there, I'm going to leave that on there for now, going back to square root of 4 times square root of 4. We talked about that in our homework when we had to do that problem. If it's a square root times a square root, you can take the numbers inside and multiply them, and you should be able to get square root of 16. And everybody knows square root of 16 is 4.
4.
But wait a minute. Did you also realize that square root of 4 is the same thing as 4 to the 1/2?
No.
Why isn't it there? Wait a minute. Mr. Konchak, it says that if this number is a 2, there should be a 2 there. Shouldn't it be?
Yes.
How come there's no 2 tucked up inside there, guys? It's assumed or implied. If it's not there, it is going to be a 2. So, the question then you ask yourself is, 4 to the 1/2 times 4 to the 1/2 is, wait a minute, exponent rules. That's 4 to the 1/2 plus 1/2, which is 4 to the, what's half plus half?
1/4.
No.
1.
Is 1. And anything to the first power is that thing, and it just ends up being 4. So there's ways to make this all happen, and it works out nicely. Okay, now, we got to simplify this problem, and this is going to take a little bit longer than our 2 minutes, so I will finish it and post the video, and you guys will have to watch it.
Alright,
Now,
important question.
here's...
Make people watch it.
Shh.
Why the 4th or is it?
You're wasting more time,
Because no one watches it.
and we're actually recording this. Now,
My bad.
we're starting off with the square root of x cubed y times, now there should probably be a little space in there to give a little extra in there, the 4th root of xy cubed. It's not y to the 4th. So the first move you have to do is switch everything to exponential form, which means you're going to have x to the 3rd y all to the 1/2 power, because the square root is the same thing as taking the 1/2 power. I then will have xy cubed to the 1/4 power. You guys agree with this?
Sure.
Hey, I got a power on a product. So I can take that 1/2 exponent and the 1/4 exponent and do what with them? Basically distribute them in. So I get x to the 3/2, y to the 1/2,
They're really trying to break it up.
x to the 1/4, y to the 3/4. Yes?
Yep.
And now I can use my exponent rules and put the like terms together because we're multiplying. I'm multiplying my x's. I'm multiplying my y's together. So when you have the same base being multiplied together, you do what to exponents? Add. So we get x to the 3/2 plus 1/4. Y to the 1/2 plus 3/4. I will continue this video on my own.
Can I ask my important?
So what happens here now, we have our exponents that have fractions with non-common denominators. So we have to get common denominators, and the common denominator between the 2 and the 4 would be 4. So what I'm going to do is multiply the top and bottom by 2 And when I do that, I end up having x to the 6/4 plus 1/4. I can do the same thing with the y to the 1/2 plus 3/4. 2 and 2. So then I have y to the 2/4 plus 3/4. And so I get x to the 7/4, y to the 5/4. I would gladly like to say that I am done. But what I also recognize is that I could put this back into radical form, because if you think about it, your fractions are kind of top-heavy right now. That means that I can actually divide 7 by 4 or get rid of some things. So to make this maybe a little easier, I'm going to switch this back to radical form. And when I do this, I end up with x, 4th root of x to the 7th times the 4th root of y to the 5th. Now, like we've been talking in class, you actually, if you have the 4th root times a 4th root, you can actually multiply those numbers inside, and I can end up with a larger 4th root of x to the 7, y to the 5th. And then, if you think about this some more, that we had to simplify. And when we were simplified, we always had to look for partners. We went to that square root dance. Well, this one's going to be the 4th root dance. And the 4th root dance says you need to have partners of 4 to go to this dance. Well, here's the cool thing. What does x to the 7th and y to the 5th really mean? Well, it means that there are 7, 1, 2, 3, 4, 5, 6, 7 x's, and 1, 2, 3, 4, 5 y's being multiplied together. What I need to do is I need to group them into groups of 4, so they can go to the dance. So those x's can go, those y's can go. Not everybody's going to this dance. But when they do go, I have an x who leaves, because when they join hands, they're leaving. They become the one of the group, and the y's get to leave, and so then I get xy on the outside, and anybody else who does not have a group of 4 does not get to go, and we put them back together, becomes x to the 3rd y. That is a completely simplified answer to our problem. Please come to class with questions. Here's your homework on page 47, 7, 8, 18, and 22. Have a great day. Be ready to be checked.